Another example for tangents and normals, we have this a curve whose equation is x squared plus, okay, this passes through a given point A, 1, 2, and B, negative 1, 0. The tangent at A and the normal at B, and the normal to the curve at B intersect at a point C. Determine the equation of the tangent at A, coordinates of C. Now this one we can start with a simple sketch in case we have to bring it out well, but even if you don't sketch, you can do the number and proceed. A is 1, 2, 1 in x, 2 in y, so that is 1, 2, that is our A. Then we have B, which is negative 1, 0, somewhere here, negative 1, 0, and this is B. So they are saying that this curve, whatever this curve is, passes through this point and that point. Now, the tangent at A and the normal at B intersect at point C. How should I draw the curve? Let me just assume this curve just passes there like that. It goes wherever it goes. I'm not saying this is the actual drawing of the curve, but let me just have something drawn that's straight. So they are saying that the tangent, let us assume the tangent is there like that. The tangent at A, they are saying the tangent at A, in case it is something like that. This is the tangent at A. They are telling us that it means the normal at B. So let me assume the normal at B cuts it at that point like that. So let us assume it is just something like that. So we have, this is the point of intersection C. We have the normal at B, then we have the tangent at A. Then they want us to first of all get the equation of the tangent, then after getting the equation of the tangent, we get the coordinates of C. So simple, this is what we are going to do. Let us start by getting the equation of the tangent at A. We are going to differentiate our curve here with respect to x, such that we get our dy of x. I'm sure by now you're experts at this. Let us do like this. This is dx, this is y squared, minus, this is our constant. I can factorize it out. I still with x, 3x, negative 3x, then this is equal to d dx. Then this is the product rule. We keep x squared constant, differentiate y, we have dy dx, plus keep y constant, differentiate x squared, we have 2xy, then plus 2y dy dx minus 3. This is equal to 0. Put the dy dx alone and we shall have dy dx being equal to, when the 3 crosses it becomes a positive, when the 2x crosses it becomes a minus 2x, then divided by the coefficient of dy dx is x squared plus 2y, like that. Since this is a gradient, we have to get the gradient at a particular point, which point is 1, 2. This is at A. So wherever there is, this is x, remember, then 2 is the y. So wherever there is x, we are putting there 1. Wherever there is y, we are putting there 2. So this is 3 minus 2 times 1 times 2. All of this is divided by 1 squared plus 2 times 2. So this is going to be a negative 1 over 5. Leave it as it is. Don't write it in points. Leave it as this fraction. So this is our value of dy dx. Now we are going to go ahead and find the equation of the tangent, which is our part A. How do we find the equation of the equation of the tangent is simply going to be y minus the y value, which is 2 over x minus the x value, which is 1. This is equal to the gradient. Then we can cross multiply There are so many ways of doing this. Some people can first get the y-intercept, but this is also okay, such that we have 5y minus 10 is equal to negative x plus 1. In simplification, we have 5y being equal to negative x plus 11 when the 10 crosses. So this is the equation of the tangent at A. And I'm going to write it somewhere, we shall need it. So we have come up with 5y being equal to negative x plus 11. This is the equation of the tangent at A. Then this one is done. Coordinates of C are at a point where the normal meets the tangent. So we are going to first of all get the equation of the normal. From this point, we have seen that m1 is equal to negative 1 out of 5. When you look at this, this is the gradient of the tangent at A. So we need to get this has been differentiated. Okay, I've differentiated this value here. Now I'm going to go at point B. At point B, the value we are substituting for at this point here is going to change a little bit. This is where I'm going to start from. And I said, because it is the same curve, so it is having the same gradient function, but the points where the gradient is got from the points are going to change a little bit. So now at B, this time around at B, the divide x at B is given by wherever there is it is negative 1, 0. B is at a coordinate which is negative 1, 0. So you substitute now for no need of differentiating the second time because you already have the gradient function. So we say 3 minus 2 times negative 1 times 0. This is x, this is y. Then over, this is negative 1 squared plus 2 times 0. So we shall have a 3 as our, this is our m of the tangent, gradient of the tangent. But at B, this is at B. But we don't need the gradient of, we don't need this. We need the gradient of the normal at B. So gradient of normal at B is simply going to be the negative reciprocal of this, which is just negative a third. So we get the equation, having established that this is tangent at A. Then you have the normal at B, which is negative a third. So it is this one that we are going to use. Get the equation of the normal, which is y, minus the y coordinate at B, which is 0, over x, minus the x coordinate, which is negative 1. It is this one that is going to be equal to negative a third. So in a cross multiply, I have 3y being equal to negative x minus 1. So this is the equation of the normal. So they said that the equation of the normal and the normal and the tangent meet at C. So it means that I'm going to solve this one here and this one here simultaneously. I'm going to solve these two simultaneously, then I get the point where they intersect. So how do we do that? It is simply going to be, we can write, I have 5y is equal to negative x plus 11. Then I have 3y being equal to negative x minus 11. This is minus 1. So I subtract. This one will give me 2y. This goes to 0. Then this one goes to 12. Dividing through by 2, I get my y as 6. If I divide by 2 on both sides, then after I get the value of y, put it in any equation and get, let me put it in this equation. I get the value of x. I'll have 3 times 6 is equal to negative x minus 1, such that x will be equal to negative 1 minus 18, so x is equal to negative 19. So I conclude, okay, my part, it has been part B, and I conclude and say the coordinates, that is the coordinates under BCSA, coordinates of C are negative 19 and then 6.